Hey, what's the deal with all this talk about nuclear fusion and nuclear fission? Are they like two versions of that stuff that powers explosions and big lights? Because I've always thought nuclear just means big boom. Thoughts?
Oh, please. Big boom is the sort of simplistic analysis I'd expect from a man who thinks a research paper is the beer menu. Listen attentively. Fission is when a heavy atomic nucleus like uranium or plutonium splits into two smaller nuclei, releasing energy in the process. Why does that happen? Because the original nucleus is unstable and the resulting fragments have lower total mass. That missing mass becomes energy, as in E=mc². Do you understand, or must I draw a cartoon?
To put it in plain terms for Peter, imagine a heavy, overloaded bookshelf collapsing into two smaller, more stable stacks. The collapse releases energy, heat, radiation, and yes, possibly a chain reaction if free neutrons from one split cause others to split. That's how nuclear reactors and some bombs work. Reactors control the chain reaction, bombs do not.
So fission is like splitting a cookie and getting crumbs that somehow make more cookies split? That sounds dangerous.
Close enough, cookie brain. Now fusion. This is the spectacularly harder, far more elegant sibling. Fusion joins light nuclei, think hydrogen isotopes, together to form a heavier nucleus like helium. Again, the resulting nucleus has slightly less mass, and that mass difference is liberated as energy. Fusion is the energy source of stars. Why isn't fusion everywhere on Earth then? Because you need immense temperatures and pressures to overcome the repulsive forces between positively charged nuclei.
Right. Fusion promises enormous energy with far less long-lived radioactive waste than fission and no risk of runaway chain reaction. But sustaining and harnessing that reaction on Earth requires containing plasma at tens of millions of degrees, very tough engineering. So we've got promising experiments, tokamaks, inertial confinement, but practical economical fusion power is still a work in progress.
Huh. So one tears stuff apart, the other forces stuff together. Both make energy because mass changes, not because of magic. Do you think we'll have fusion power in my lifetime? Or will I still be paying for electricity and bad cable TV?
That is the million-dollar question, isn't it? Or perhaps the gigawatt question. What technical or political hurdles would we need to clear to make fusion ubiquitous? And how would that reshape society?
And don't forget ethical and economic questions. Who controls the technology? How do we distribute cheap, abundant energy? And what environmental impacts remain? Energy transitions aren't just about physics. They're about policy, investment, and human choice.
All right, now I'm curious. So what's the next step? Watch a documentary or build a tiny sun in the garage?